Hello friends, welcome to my channel. In this video, I will explain about a code generation algorithm friends. Okay, so this concept belongs to compiler design subject. This is one of the most important question for BTech examinations and university examinations friends. Okay, so first we will see what is meant by code generation. Code generation is the final phase of a compiler where intermediate code is transformed into target machine code friends. Okay, so remember, code generation is the final phase of the compiler and intermediate code will convert into target machine code. Okay friends, so now we'll see the algorithm. You can observe it uses getReg function to assign registers to variables. Initially, it uses the function called as getReg. So what is meant by this getReg? Get register. Okay, to assign registers to variables. In order to assign registers to variables, we will use the function called as getReg friends. Okay, so again it uses two data structures. First one is called as register descriptor. Second one is called as address descriptor friends. Okay, so what is the use of this register descriptor? What is the use of this address descriptor? Remember, register descriptor is used to keep track of which variable is stored in the register. Okay friends, address register is used to keep track of the location where the variable is used. Okay, so this register descriptor is used to keep where the variable is stored and address register where the location. Okay, it focuses on location friends. Okay, so let us move. Now you can see register descriptor is used to keep track of which variable is stored in the register. Okay friends, address register is used to keep track of location where the variable is used. So remember, register descriptor is focused on which variable is stored, and in the address descriptor the location where the variable is stored. Address means location. Okay friends, register descriptor means which variable is stored. Let us see one example. By the way, you will get more clarity friends. So you can see here the following actions are performed by code generation. X is equal to y op z. So x is equal to y op z. Op means here operator. Okay, so you will take any operator, addition, subtraction, minus and star, division. Addition, subtraction, multiplication and division. Now there is one example is there, x is equal to y op z. With this example we will see how this code generation will going to work. Okay friends, so x is equal to y op z. Step 1 in the step, so this is the example. In the step 1, invoke a function getReg to determine the location of L where the result of computation y op z should be stored. Okay, so you see x is equal to y op z is there. Let us say the op value is plus, so y plus z, it is used to store some location. Okay, so invoke a function getReg. So we are using method called as our function getRegister to determine the location of L where the result of computation y op z should be stored. This result location, let us say L friends. Okay, so in order to store this y operator z, we are using the location L. So we are going to call the method called as getRegister y comma z. So remember, x is equal to y op z. So the computation result can be stored, let us say the location L friends. So this is called as a step 1. In the step 2, determine the present location of y by consulting address descriptor of y. If y is not present in the location L, then generate instruction move y dash comma L to copy the value of y to L. So remember, first we store the result of y opz into the L. Now I am finding the location. You see, determine the present location of y. Yes, determine the present location of y. So you know there are two descriptors are there. First one is called as register descriptor. Second one is called as a address descriptor. In order to find the location of y, we will focus on address descriptor, friends. Okay, so address descriptor of y. If y is not present in the location L, okay, so already we compute y opz. Suppose if at all the location, if y is not present in the location L, then generate instruction. Okay, so you generate instruction move y dash comma L. Remember, in place of y, I am going to analyze, I am going to thinking y dash comma L. So now y dash will be placed onto the L, friends. So to copy the location of y to L. Okay, so now I am copying this location into the L. So remember, till now we completed step 1 and step 2. In the step 1, we are going to store the result of y opz, that is called as the location is L, by using get register method. In the step 2, we are going to find the present location of y. If it is not there, then you are going to find the location of y. Let us say y dash, move y dash comma L. So again I want to send this y into the L. Okay friends, in the step 2, remember, determine the location of y in the step 2. In the step 3, determine the location of z. Okay friends, so when you determine the location of z, same step is there. Determine the present location of, instead of y you say z, by consulting the address descriptor of z. If z is not present in the location L, then generate the instruction move, instead of y dash, so we can say z dash comma L to copy the value of z to L. Okay, so initially we find the location of y in the step 2. In the step 3, we will find the location of z, friends. Okay, so you can see, friends, step 3, determine the present location of z by consulting the address descriptor of z. If z is not present in the location L, then generate instruction move z dash comma L to copy the value of z to L. Okay, so when there is a y opz, first we find the location of y. In this we talk about the location of z, friends. Okay, so this is about the step 3. Now when we go for step 4, you see, now L contains the value of y opz, you know. So first we find the location of y, then we find the location of z. So that's why he is saying, now L contains the value of y opz, that is value assigned to x, because x is equal to y opz, friends, you know. So if L is a register, then update it register descriptor to show that value register L contains the value of x. Okay, so when the x is equal to y opz, we need to update the register descriptor, then only the location will be assigned to x. Okay friends, so here you can see he is telling like x is equal to y opz. First you find the location of y, then you find the location of z. After completion of this one, in the step 4, you update this register descriptor. Okay, so you can see, when you update the register descriptor, this y opz will be assigned to x, friends. Okay, So in the step 5, if y comma z has no future use in basic block, then update address descriptor, then remove from the register descriptor. Okay, so after completion of working with this y, op, z, so y, z values you used, the value is completed. Then what you have to do? You need to do something called as, you need to remove from the register descriptor. Okay, so if y comma z has no future use, so I don't want to use y and z in future, then we need to remove from the or else register descriptor, friends. Okay, so you need to update the address descriptor and remove from the register descriptor, friends. Okay, now here you can see one example, a minus b plus a minus c plus a minus c, friends. So what we are going to do, we are going to convert this one into code generation. Okay, friends, you can see initially I took the value of t, okay, t as a minus b, t is a minus b, okay friends, u is a minus c, the value of t is a minus b and the value of u is a minus c, friends. Okay, so then what is going to be happen? You can see a minus b plus a minus c. So the value of a minus b is t, the value of a minus c is u. So v is equal to t plus u. So this is called as t, this is called as a u, friends. Okay, so now what we have to do? In the next you can see d is equal to v plus u. So what is this v? What is this v? T plus u, a minus b s plus a minus c t plus u. So what is the value of v? V means t plus u means a minus b plus a minus c. This is v plus u. Again, what is the value of u? U means a minus c, friends. Okay, so now I will show how this code generation will perform in this. Now here is the example for code generation. So already we have an example like a minus b plus a minus c into a minus, right, friends? You can see in the left side you write one by one statement. So first one is t is equal to a minus b. Okay, friends, so what you have to do now? There are 4 columns are there. First one is the statements, second one is the code generated, register descriptor and address descriptor. Initially the register descriptor is empty. When t is equal to a minus b, okay, so what you have to do? Move a comma r naught. So I am sending the value of a into r naught. Okay, friends, so now the value of a is available in the r naught. So I want to subtract a minus b. So r naught is available on a. Then I want to subtraction with b. So subtraction of b comma r naught. Actually r naught is having a. Okay, friends. So when it comes to register descriptor, r naught contains t. Okay. So actually the result is stored at t. Register talk about the result t. R naught, this R naught contains the t. Okay, friends, address descriptor, in the address descriptor t in R naught. So the location, address location is t in R naught. Next you see u is equal to a minus c. Okay, move a comma r1. So R naught is already completed, then we come for r1. Move a comma r1, then subtraction c comma r1. So subtraction c comma r1 means we are going to subtract a minus c, friends. Okay, so then what you have to do? R naught contains t. Yes, already R naught contains t. Then r1 contains u. R1 contains u because the result is stored at u. That's why we talk about the R1 contains U and U in R1. Yes, U in R1 friends. Last one is a V is equal to, sorry, third one is a V is equal to E plus U. So now what I am going to do, actually what is V? T plus U. So T is in R0, U is in R1. I want to add T and U, R0, R1. That's why add R1 comma R0. Now you see here, R0 contains V, R1 contains U. R0 contains V because when you add two numbers, add R1 comma R0, the result is stored at R0. That's why R0 contains V. Okay, then R1 contains U. R1 contains U friends. Okay, so next one, U in R1, V in R0. So because you see, add R1 comma R0, the result is stored at R0. That's why R0 contains V and R0 in V. So last one is a D is equal to V plus U. Add of R1 comma R0, move. You see this one, V plus U. How to add V plus U? These two friends. So V is in, you see, move R0 comma, so add R1 comma R0. So these two results, V plus U, these two, R0 and R1. So finally R0 contains D. Yes, R0 contains D. So D in R0. So this is all about the code generation algorithm friends. So you can see, if at all you want this notes, you can ask me. Thank you for watching this video. Please subscribe my channel. Thank you friends.